Alright, welcome to Mr. Vranick's Honors Algebra 2 class. This is the first video of many. We're going to start off the year talking about sets of numbers, and then we're going to categorize numbers based on what they are. We're going to talk about different properties of real numbers, and then close it off with a problem for the first video. So, let's just get started. Sets of numbers. We have everything is complex, so every single number you see will be in the area of complex, and then that splits down into two of them. We got real and imaginary. Imaginary numbers are numbers that do not exist, such as the square root of -4. Okay, there's nothing that you multiply twice of itself, so -2 times -2 becomes positive. 2 times 2 is a positive 4. Nothing, you can't get a square root of a negative number. Real numbers then are all the other numbers that exist. Those are broken down into rational and irrational. Okay, so let's start with irrational. Irrational numbers are basically decimals, but they cannot be written as a fraction. And what that means is most decimals that terminate or end, they can be written as fractions. So these decimals will never end. They go on forever, and they do not repeat either. So they do not terminate or repeat. Some examples of that are the symbol pi. The symbol pi is an irrational number. That goes on forever, never repeats. Another thing that is irrational would be something like the square root of 5. It's not a fraction, you can't write it as a fraction, it's irrational. Rational numbers are then the opposite. They basically can be written as fractions. Or repeating decimals. Okay, so we have irrational, that's where that branch ends in real numbers. Then we have all the rational numbers. So every number you know pretty much that you work with is rational. It can be a fraction, it can be a whole number, it can be an integer or a natural number. So we're going to now go to these three things where people sometimes get a little bit more confused. An integer just means that it is not a decimal or a fraction, so it's no decimal or fraction. So basically it's all numbers, all negative and positive numbers. So that's this one here. So starting at negative whatever, 20, -19, 18, and so on, 0, 1, 2, 3, that is what integers are. There are no decimals, no fractions. Now we have whole numbers, which are basically we take away the negatives. So whole numbers are just 0, 1, 2, 3, etc. So integers can be negative or positive. Whole numbers start at 0 and go positive. 0 is also included in the integers. And then natural numbers or counting numbers, well, generally when you count, you start at 1. So the only difference between whole and natural is that 0 is not included in the natural numbers. Okay, so those are all the different ones. And by the way, if you are ever behind on the writing, you can always just scroll back, or you can pause it to write down something and get it down. So let's just look at these three examples. If you want to try them yourself, you could pause the video and see which elements they all are. I'll do the first one so you can see what's going on. Now this is tricky because it looks like it's repeating, but when I say repeating, I'm not saying a pattern. It has to actually repeat. Well, there's 1 0 here, there's 2 zeros here, there are 3 zeros here. It's not actually repeating, it's going up in zeros. So this cannot be written as a fraction. It is a complex number. Complex. And then it because it is not imaginary, it is a real number. But then we have to say that it's irrational because it goes to it does not have a fraction. It doesn't repeat or can be written as a fraction. So now B, again, you can pause these and try them before you do them. B is tricky because you look at that and go, it's a fraction, so we're going to go all the way to rational and stop. However, before you do that, double check and see what it is. We have 21/7. That is 3. 3 is basically everything down that left branch of your table up above. So we have complex, real, it's a rational number because that can be written as a fraction as it was. It is an integer. It is part of the whole numbers because it's positive, and it is a counting number or a natural number. So that would fall under everything down that left branch. Finally, can you take the square root of -25? No, you can't. So we always start with complex. Every single answer should have complex, and then this would be imaginary. Okay. Now, we're going to finish up with the second page. These are just some properties of real numbers, so let's do those. Okay, closure is the one that I'm going to talk about down below. That's one that you might not be familiar with. All that means is it remains in the set if the two letters are real. And what that means is so if I say A and B are real, then if I add A plus B together, you should get a real number. If I say A and B are real and I say that they have a property of closure, that means when I multiply them together, they are also real. Okay, I'll go into that down below because that one's the one that's confusing. So, commutative property. That's basically one way or the other. Okay, so think when you do a commute to work, usually you go to the place and then back. So for addition, that's just saying that if I add two numbers together, A plus B, and I add them in the reverse order, it is the same thing. Same thing with multiplication. There's just two numbers. Your commute is just two different, usually two destinations, the starting and the end, and then you can go backwards. So think commutative like commuting. Alright, associative. Associative is where we have the three elements with grouping. So that's just saying that if I add A plus B first and then C, that is the same thing as A plus B plus C. Okay, and then you can do the same thing with multiplication. If I multiply A times B times C, it's the same thing as if I multiplied A first times, or I'm sorry, B and C first and then times A. These are more important. An identity element. Identity means that you get the same thing out. So you get out the same number. So for addition, if I have a number A, and for addition I have to add what to it to get to A again? Well, for addition it's 0. So the identity element is for addition you add 0 and you get back A. For multiplication, I have to multiply something to get to A. Well, A times 1 is A. So whenever you're doing a multiplication identity, you're multiplying by 1. So you get the same thing. An inverse means it's kind of the opposite of what we just did. For adding, they add to 0. So if I add A and then I add the opposite of A, I'm going to get 0. So it's the opposite of the identity element. What gets us to 0? For this one, it's what gets us to 1 with multiplication. Well, if I want a 1 and I have A, I have to divide by A, or if we're using multiplication, it's the same thing as multiplying by 1 over A. Okay. Now for this thing, A cannot be 0 because you cannot have a 0 on the bottom, so the number 0 can't be used in this example. And another way to write inverse would be A to the negative first. This is the same thing as this one. If you've done exponent properties before, you should know the negative exponent flips it. So, and finally, distributive property. That's just, you guys have done that before, I hope. But let's look at it again. If I have an A outside, B, and then B plus C inside, I have to distribute to both things. So AB plus AC. Alright, so let's finish up with these problems. This is what we talked about closure at the top. Again, if you didn't understand it there, you might see what I'm talking about with these. So answer yes or no. If no, give a counter example. So if no, tell me why. Why is this wrong? So are the even integers, so even numbers that are negative or positive, closed under subtraction? Okay. so let's see. We can do 4 minus 2, and I get 2. So I have an even, and I got out an even. So that works. However, we have to check the negatives too, because we're talking about integers here. What about negative 2 minus a negative 4? Okay, negative 2 minus a negative 4. That's negative 2 plus 4, or 2. So I have another even, even, even. Are they closed under subtraction? Yes, they are. It's closed because when you get any two even numbers and subtract them, you will get another even number. That's what closure is. I tell you what numbers to use, you check them, and then if you get the same thing out that you put in, it's closed. So, are the odd integers closed under addition? Let's do odd ones. Well, let's do 1 plus 3. 1 plus 3 is 4. Did I get an odd integer out? No, this is even. So I have odd, odd, and even. There's no closure here, and this could be your counter example. I showed you it right there. It does not work. Okay, so you can pause right now if you want to see if you could try C. And I'm going to do it right now. So pause if you want to do it. Are odd integers closed under multiplication? Let's do 1 times 3. You get 3, so that works. Let's do 3 times 5. Those are both odd integers. You get 15. That works. So if it works a couple times, chances are it's working for all of them. So we can say, yes, it has closure. Alright, so finish up day 1 of the notes. We have exchanging $500 for Mexican pesos. The exchange rate is 6 pesos per dollar. Assume that you use other money to pay the exchange fee. So we're just doing a direct exchange. If you want to try this before or see if you can do it, a lot of you could probably do this without my help. So, but if you can't, here's what we do. We start with $500, and we know the exchange rate, so we're going to multiply it by an exchange rate. Well, you want to cancel out the units, so we're going to have dollars on the bottom, and we know it's $1 for 6 pesos. Alright, that cancels our dollars out. You'll be doing this in chemistry if you're in chemistry. And then you can multiply the numbers, and you're in pesos. This is the same thing as saying 3,000 pesos. Please show your units, very important. And finally, when you return, you have 270 pesos left. How much can you get in dollars? So we're just doing the reverse. So I start with 270 pesos times, now I need pesos on the dollar, and I know it's 6 pesos because that's what they told me, for $1. So basically for this one you're going to be dividing. So 270 times 1 divided by 6, you should get $45. So if you got those right, I'm okay with just the symbol for the units there, but I do need the dollar sign, or you could write out dollars. Okay, that is day 1. Again, if you have any questions, post on Edmodo in the comments section, and I will cover them at the beginning of class tomorrow.